Okay.
Yes.
All right. Here we're starting Mod 8, and Mod 8 is we're learning about energy and work. Energy is the ability to do work, and work is force applied over distance. If there's no distance, no work has been accomplished. Here we have a formula for it. Work is force parallel. That's what those two little marks mean. So force parallel times a distance that is accomplished. So if this little child pulls on the wagon but cannot move it, he can pull for hours and be sweaty and tired, exhausted, but no work has been done unless he pulls at a distance. So,
Wait,
if
how would
he,
he, I mean, what if he just stood still but then pulled it toward him?
what's that?
What if he just stood still and pulled it toward him?
As long as he's moving the wagon moves.
How would he do anything without the wagon?
Well, like if you push on this wall all day, I doubt that you'll move it.
I mean, you're applying force to it
So
though.
yeah, there's force applied, but no work has been done. All right, so force parallel. Here I've drawn the fact that the child is pulling in a parallel direction to the motion of the wagon, so all the force is parallel. If he was pulling at an angle, we would only include the force that was the component that was parallel. So we're not going to study those kind of forces in this mod. I just wanted you to know about it. All right. The next part that we usually ask is what kind of unit is involved with this. So let's take work equals force times force parallel times x. So let's put in a unit. So Zach, what's the unit for force? Newton if we're in metric land, pounds if we're in America, and x is, the distance is in meters. So we end up with Newton meters. Have we seen those before? Torque had Newton meters as well. All right, when we're measuring work, we actually renamed it. We didn't rename it for torque, but we renamed it for work. So, and we rename it in honor of a physicist. His last name was Joule. So we call it a joule, and it's symbolized with a J. So we're working in joules.
Isn't that like when they're trying to shock someone, they're like 200 joules?
Do they?
Yeah. Well, I mean, at least they do
It
it.
has
on
something to
TV.
do. Okay.
I just remember
You've
that.
heard
'cause I was
that?
watching
Okay.
it last night.
All right. I remember about, my daughter is 27, one of them, the younger one. The 27-year-old, I was pregnant with her. Can you believe I've been teaching that long? What is wrong with me? Well, 27 years ago I was pregnant. I was teaching this, and the class begged me to name the child Jewel. So of course, I probably wouldn't have spelled it that way.
Yeah.
Yeah, it's kind of.
But I did it. So anyway.
Could have made her middle name Jewel.
Alright. I could have. Alright. So,
My daughter. Whatever beer. Yeah. I read a book.
alright, we can't leave, we cannot leave until we do a problem. So, if you would, draw a bike. Those are the hardest things to draw. Someone on a bike.
What about the seat?
Yo, this is the ass cam. Eyes closed, perfect circle. I'm like, what?
She can.
Alright.
Like, even with the ruler, I can't.
Someone is on a bike, and the bike is being pushed with a force of 15.1 newtons. So the muscles and the pedal combination creates a force of 15.1 newtons. And the bike is going to move a distance from that force, and it will move 0.213 kilometers. And I want you to find the work. We're going to use the formula. Work is force times distance. Please work in meters so that we may use the word joules. So switch from kilometers to meters before you multiply.
You can do it now.
Are you placing in the formula, are you replacing force with 15.1 and x with 213? Because that's how many meters there are in 0.213 kilometers. With that, what is the final answer?
2,201.
Are you serious right now? I'll see it.
3.22. How many sig figs? Looks like we got 3 going. Wow. 3.22 times 10 to the 3.
Oh, we're doing that, so.
1, 2, 3, or you could say 3,220. That's also 3 sig figs. So you don't really have to use scientific notation. And then add the unit, the new unit we met, joules.
So if we were to put like Newton meters, would that be wrong?
Yes, it's newtons is part of the idea because that's the force part, but work is not in newtons.
No, she said if you put Newton meters.
All right, Newton meters is right.
Okay.
Okay, I couldn't mark that wrong because it's right. It would go against my teacher's soul. All right, I don't mark things that are right wrong. Sometimes I do. I had a student once, and she was the sweetest thing, but she wasn't real engaged. And so, in my math class, I would take her paper and mark some things that were right, wrong, just to see if she would ever ask about them. But in the grade book, I put it incorrectly, you know. So the first day I hit it back, doesn't say a word. Second day, doesn't say a word. About a week into it, she said, I think this one's right, and then I told her what I was doing.
That's so funny.
That was
Do you
me,
do that with
wasn't it?
us?
What?
Do you do that with us?
Ah, you'll never know, huh? You better watch. All right.
I gotta check all the answers.
The next definition I need to give you goes in a whole new direction, so we'll just shut it down there and pick that up
If you got 5 wrong,
Monday.
it's
Yeah.
like a 90.
So, on your homework, what does it,
tomorrow.
on that paper, who has it in front of them still? Emily, what's it say the homework is?
Complete take-home open book test, mod 7.
All right, so please remember that you have that to do.
There you go, pal. That's what she told
All right.
me.
I will see you on Monday,
Being mean.
if not before.
I love you,
All right, shut it down. Bye.